Greetings to our grade 8 learners and welcome to the term 2 of your current academic year. And I'm certain learners, we may have often pondered on this question. How come different areas on the surface of the earth experience different temperature and or rainfall? Sometimes you may travel from Durban, which is a coastal city, and you might move to Gauteng, which is an inland city, an inland location, and we experience differences in the temperature. Durban might be warmer, Gauteng would be colder, and we want to give reasons for it. Or places near the equator will be warmer as compared to places along the poles. Areas along the east coast of our country will experience a warmer temperature and have more rainfall as compared to areas along the west coast. So this section, which is referred to as climatic regions, attempts to answer those questions. Now, you could be asking yourself, what does a climatic region mean? A climatic region refers to an area with distinct climate. And we speak of a tropical climatic area or a Mediterranean climatic area or a polar climatic area. So what then does the word climate mean? Climate refers to the condition of the atmosphere as experienced over a long period of time. And this could possibly mean over a number of years. And over those years, a pattern has emerged. For example, we may speak of an area which receives rainfall in summer, or other areas that receive some amount of rainfall during winter, like the southwestern Cape. So the word climate again, refers to the condition of the atmosphere as experienced over a long time period. And its counterpart, the word weather. Weather refers to the condition of the atmosphere as experienced over a short time period. For example, on a daily basis, we say the temperature is cold or the temperature is hot. So temperature refers to how hot or how cold it is. And you find that the word climate again is a condition of the atmosphere as observed over a long time period. The word weather is a condition of the atmosphere as observed over a short time period. And here are some of the elements of weather. We speak of the temperature. Once again, you can see, for example, here that you may have snow on the mountains. And perhaps you ask the question, why do the mountain areas have snow as compared to other areas? And this section attempts to explain that. Then you have precipitation, which is also an element of the climate of an area. We speak of the area's humidity. We speak of the wind of the area, the wind in the area. So all these areas here are talking about the climatic elements of an area. Now, when we speak of why do certain areas experience differences in temperature and rainfall, then we have to speak of these 5 factors. These 5 factors are responsible for the differences in temperature and rainfall in different parts of the world. But of course, our focus is going to be in South Africa. And the 5 factors in no particular order are latitude, sometimes referred to as distance from the equator. We speak of ocean currents and how they influence temperature and rainfall. We speak of distance from the sea. Yes, you are right. The climate of areas along the ocean would be different from areas that have a continental location. We speak of the influence of altitude on temperature and rainfall. And we also speak about the influence of relief, the mountains, on the influence of temperature and rainfall. And our subsequent lessons will focus on each of these things. But today's lesson focuses on the distance from the equator, which is latitude, and how this factor influences temperature and rainfall. And of course, temperature and rainfall influences the vegetation of the area. And we'll speak about that as well as we tend to move on. In this resource, there we have the equator. The equator being a line of latitude. Hence the factor latitude or distance from the equator. And you'll note there's the latitude, there's the equator, which is our line of latitude. And if you travel that way, you're now moving to the northern hemisphere, and there's a North Pole up here. Now, as you might know, that areas along the North Pole constantly have snow, constantly have ice. And there's the equator. The equator is warmer. People living along the equator tend to experience endless summer, which means that it's summer throughout the year. And as you move away from the equator, temperature is going to decrease. Once again, the equator is going to be a warmer area. The equator is warmer and the poles are colder. Right? There's the equator. The equator is going to be a warmer area and the poles are going to be colder. Again, temperature decreases as we move away from the equator. Now, there are 2 very simple reasons why the equator is warmer. One, the sun strikes the equator almost directly, isn't it? The sun strikes the equator almost directly, covering a smaller area. Note the area covered. The sun strikes the polar areas almost obliquely, and there's your angle there, almost obliquely. So the sun is striking the equator directly, covering a smaller area. Therefore, the equator is warmer, whereas our sun's rays strikes the poles at an angle, covering a larger area, and therefore it's going to be colder. The second reason why the equator is going to be warmer is the area that we speak about here, and this is the atmosphere. So this area around the Earth is called the atmosphere. The atmosphere is a layer of gases that surround the Earth. So at area B, which is near the equator, the sun's rays is striking directly and it has to pass the atmosphere. No different from area A, the sun's rays striking that way and it has to pass the atmosphere. If you note carefully that area B has a smaller atmosphere, whereas area A has a larger atmosphere. Now, because area B has a smaller atmosphere, it means that a smaller atmosphere will have less dust particles, less smoke particles, less pollutants, less cloud particles, and less smoke particles, less pollutants, less dust particles mean that more of the sun's rays will reach the Earth's surface. It means that at this area here, there'll be less scattering taking place. There'll be less reflection taking place. There'll be less absorption taking place. So less reflection, less scattering, less absorption by the particles found in the atmosphere, which means that more sun's rays will reach the ground. Whereas in this area here, because you have a larger atmosphere, there's a big possibility that you'll have more dust particles, more clouds, more smoke particles, and those particles are going to reflect the sun's rays back to the atmosphere. As a result, less sun's rays will reach the Earth's surface. So once again, the equator is going to be warmer for two reasons. One, the sun's rays will strike vertically, covering a smaller area. So the sun's rays is more intense. The sun's rays is now direct, covering a small area. The second reason has to do with the amount of atmosphere. At the equator, the sun's rays is passing through a smaller atmosphere. And that means less of the sun's rays is going to be reflected back to the atmosphere. Less sun's rays will be scattered or absorbed by the dust particles and smoke particles that are there. So if less is going to be reflected, less will be scattered, less is going to be absorbed by the smoke, the pollutants, the clouds. That means more of the sun's rays will reach the equator. The opposite now takes place here. The poles are colder because the sun's rays is covering a larger area. There's it. It's covering a larger area. The sun's rays is now scattered over a bigger surface area. Number two, the sun's rays has to pass a larger atmosphere. And that means there's a big possibility that more of the sun's rays is going to be reflected, scattered, and absorbed by the particles in the atmosphere. If more is going to be scattered, absorbed, and reflected, the chances are that less is going to be able to reach the Earth's surface. Therefore, the poles are going to be colder. So once again, the temperature decreases as you move from the equator towards the polar areas. Now, if one examines the equatorial areas, and one will speak of the equatorial areas, and there's a minute here, one will speak of, there's there, right? That's the same diagram again, showing us that there's the equator sun's rays direct, smaller area, smaller atmosphere, and more intense. Here, sun's rays striking over a larger area, greater atmosphere, less sun's rays will reach here, and therefore the poles are going to be colder. All right, we're going to look very quickly at, there's our tropical rainforest. Now, the tropical rainforests are the areas along the equator. There's an equator running through here, and along the area, we have the tropical rainforest. Now, we did say earlier that the equator is going to be warmer, and because the equator is going to be warmer, there'll be more convection taking place. What is convection? It's warm air rising. And because more warm air rises, there's a bigger chance of rainfall in this area. So along the equator, the area has received plenty of sunshine, and therefore plenty of rainfall, and therefore you're going to have dense vegetation. It makes sense that rainfall and temperature will influence the vegetational growth of the area. So along the equator, the areas are going to be, there's it here, lots of rainfall, high temperatures, and therefore you're going to have dense vegetation. Now, if we examine our graph of a tropical climate, Note earlier I spoke about the climatic zones, climatic regions, and the tropical climate is one of those climatic zones or climatic regions. Now there's your bar graph, which talks of the rainfall or precipitation. And there's your line graph that shows you the temperature of the area. And if you look closely, there's our temperature. If you look closely, there's your temperature reading on the side here. If you look closely, you'll find that there's your temperature graph going almost there, which means that every month, January, February, June, July, August, September, November, December, the temperature is almost the same. And if we ask to give a reading, we'll probably say our temperature is roughly in the area of about 27 to 28 degrees Celsius. So the areas along the equator are experiencing a temperature of 27 to 28 degrees Celsius throughout the year. We know why. Sun's rays strike directly. The sun's rays is passing through a smaller atmosphere, and therefore more sun's rays will be able to reach the Earth's surface. There's our graph showing precipitation. And rainfall is one part of precipitation. And again, if you see, there's our information here for precipitation, and you'll note that 500 millimeters per month. So on average, in the month of January, it's almost 550 millimeters per month. For the month of February, it's just over 500 millimeters of rainfall per month. Now, some areas receive this amount of rainfall for the entire year. But our tropical areas are getting high rainfall. Check the month of May. We've gone well over almost 650, the month of May and June, almost 650 millimeters of rainfall. The lowest rainfall is recorded in the month of December, which is just over 500 millimeters per annum. So this high rainfall throughout the year and the warm temperatures throughout the year has given rise to the tropical rainforest, this dense vegetation. Once again, this warm temperatures throughout the year, this high rainfall throughout the year is as a result of distance from the equator. By contrast, if one looks at the polar areas, we now tend to have a polar climate. There's our polar areas, right? The areas along the poles, there's it there, along the polar areas. There's our South Pole. One will note along the polar areas, there's our climatic information. And you will note the rainfall graphs are very low. Month of January, there's our rainfall here. We're receiving about 18 millimeters for January, as compared to 550 millimeters for the month of January near a tropical area. If one looks at the month of June, we've gone to perhaps 22 millimeters for the month of June. It's about the highest rainfall for the polar climate. So the rainfall in the polar areas is low because our temperatures are low. And if we examine our temperature graph, you'll note here, there's our temperature graph. There's January, you'll note the temperature is going down, it's decreasing all the way, it's decreasing, it's recording the lowest temperatures in the month of July, August, and September, and it tends to go up thereafter. And you note again, you look closely on the side here, our temperatures are negative temperatures. It's a minus degree Celsius. There's our 0 degrees Celsius temperature here. So all the temperatures for this area, look at our polar areas, record a temperature of minus degrees Celsius. Some areas, there's it here, in the month of August, the temperature is roughly about 28 minus 28 degrees Celsius. Once again, if we go back here, there's our polar areas. We're saying the polar areas are going to be colder. And as you can see, the polar areas are going to be colder, as you can see here. And of course, that is now going to influence. Right? There's your polar areas there, there's your climatic areas there, and here we're saying along the polar areas, our temperatures are on average, in some cases, minus 40 degrees Celsius, which is well below freezing point. Our rainfall is going to be low, and the rainfall is low because of lower temperatures. Right, so there's the aspect showing us those. So to conclude this section very quickly, just to recap in a minute or so, we're saying that the equator is going to be warmer, the poles are going to be colder, and because the area here is warmer, it's going to have greater rainfall, and therefore we saw earlier the dense vegetation. Our areas along the poles are going to be colder, the rainfall is going to be very much lower, and that certainly influences the kind of vegetation, the sparse vegetation that that area is going to enjoy. Boys and girls, thank you very much. And our next section will focus on ocean currents and how they influence the differences in temperature and rainfall between the various areas on the surface of the earth. Thank you. You have a pleasant day.